Paper is a material we encounter daily, serving countless purposes from books and packaging to hygiene products and art. Yet, the process of turning raw materials like trees into finished sheets of paper remains a fascinating blend of science, craftsmanship, and sustainability. This video delves into the detailed stages of papermaking, exploring the raw materials, manufacturing processes, historical evolution, and environmental impacts of this essential material. 1. Wood pulp. Wood pulp, the primary raw material for papermaking, is sourced from trees, typically softwoods like pine and spruce and hardwoods like oak and birch. Softwood fibers, being longer, impart strength and durability, making them ideal for packaging materials, while hardwood fibers are shorter, lending smoothness and a fine finish to writing and printing paper. Globally, about 50% of wood harvested commercially is used for paper production, according to the Food and Agriculture Organization. To ensure sustainability, managed forests and certified suppliers like those under the Forest Stewardship Council are increasingly employed. Additionally, efforts are being made to improve the efficiency of fiber extraction, reducing waste and conserving resources. However, challenges persist, including the balancing act between industrial demands. 2. Recycled paper. Recycling is a cornerstone of sustainable papermaking. Around 64% of paper consumed in the U.S. was recovered for recycling in 2022, according to the American Forest and Paper Association. Recycled fibers are processed by de-inking, cleaning, and repulping used paper, creating new material while significantly reducing waste. Although recycled fibers degrade after several cycles, limiting reuse to about 5-7 times, they are essential in reducing the industry's dependence on virgin wood pulp and lowering carbon footprints. Moreover, using recycled materials consumes less water and energy compared to processing virgin fibers. 3. Non-wood fibers. Non-wood fibers like bamboo, hemp, and bagasse, sugarcane residue, offer viable alternatives, especially in regions with limited access to wood. For instance, India and China utilize significant amounts of agricultural residues for paper production, with bagasse being a notable contributor. These materials are often used in specialty papers, including eco-friendly notebooks and certain packaging products. Besides their renewability, non-wood fibers typically require less energy to process, further enhancing their sustainability profile. However, integrating these fibers into mainstream production faces 4. Additives and fillers. To meet diverse functional and aesthetic needs, additives and fillers like calcium carbonate, kaolin clay, and sizing agents are incorporated during papermaking. Fillers enhance smoothness, opacity, and printability, making them indispensable in high-quality papers. Sizing agents like rosin or synthetic polymers control the paper's absorbency, ensuring suitability for various applications such as writing or inkjet printing. Bleaching agents, including chlorine dioxide and hydrogen peroxide, are used to whiten the pulp. Though environmentally harmful, chlorine-based methods have largely been phased out in favor of elemental chlorine-free and Step 1. Pulping the raw materials. Pulping is the foundational step in papermaking, where wood chips, recycled paper, or alternative fibers are broken down into a slurry. In mechanical pulping, wood is ground using large rollers, producing high yields but retaining lignin, which may yellow over time. In contrast, chemical pulping, e.g., craft process, dissolves lignin using chemicals like sodium hydroxide and sodium sulfide, yielding stronger, more durable fibers. The craft process accounts for about 80% of the world's wood pulp production, as noted by the FAO. Recently, advances in enzymatic. Step 2. Cleaning and screening the pulp. Once pulped, the material undergoes rigorous cleaning and screening to remove contaminants such as dirt, sand, and residual inks. Modern systems use centrifugal cleaners and fine screens to ensure uniform fiber quality. Technologies like dissolved air flotation systems have been adopted to efficiently separate inks and particles, particularly in high-volume recycling operations. Proper cleaning ensures that the resulting paper maintains consistent strength. Step 3. Bleaching and paper formation. Bleaching is crucial for producing white and bright papers. While chlorine was once a common bleaching agent, its environmental consequences led to alternatives like oxygen, ozone, and hydrogen peroxide. According to the Environmental Paper Network, chlorine-free bleaching can cut harmful emissions by 90%, marking a significant improvement. Following bleaching, the pulp is diluted with water and spread evenly over a wire mesh in the paper machine, where fibers interlock to form a continuous sheet. The water drainage system and suction devices ensure even thickness and remove excess moisture, setting the stage for the next phase. Step 4. Pressing and drying the paper. After initial formation, the wet paper is pressed between heavy rollers, reducing moisture content and compacting fibers for increased strength. Modern paper machines, like the Fourdrinier, can press and dry at speeds exceeding 2,000 meters per minute. Drying typically involves heated cylinders or air drying systems, bringing moisture levels to around 4 and 6%. Efficient drying not only reduces production costs. Step 5. Cutting, finishing, and quality control. In the final stage, paper is cut into standardized sizes or custom dimensions, depending on its end use. Finishing treatments like calendaring, smoothing, or coating, adding gloss or resistance, may be applied to enhance surface properties. Rigorous quality control measures, such as thickness testing, brightness checks, and tensile strength evaluations, ensure that the product meets industry standards. Advanced sensors and digital monitoring systems are now commonplace in modern mills' output. The history of papermaking. The history of papermaking is a testament to human ingenuity and innovation, evolving from its origins in 105 AD, when Kai Lun of China created the first paper sheets using mulberry bark, hemp, and fishing nets, to a global industry revolutionized by technology. Kai Lun's invention provided an affordable and portable medium for record-keeping and communication, replacing cumbersome materials like bamboo, papyrus, and animal skins. The knowledge of papermaking, initially a Chinese secret, spread via the Silk Road to the Middle East and Europe, where it laid the groundwork for further innovations. The Industrial Revolution in the 18th century marked a major turning point, with the invention of the continuous papermaking machine by Nicolas Louis Robert in 1798, later refined by the Fourdrinier brothers. This period also saw the replacement of costly rags with wood pulp, drastically reducing costs and democratizing access to printed materials, fueling education and mass communication. In modern times, the paper industry has embraced advanced technologies like robotics, automation, and AI to optimize production, while sustainability has taken center stage with Europe achieving a 73.9% recycling rate. Innovations in bio-based coatings and alternative fibers continue to expand paper's applications. Environmental impacts of papermaking. The environmental impacts of papermaking are significant, encompassing deforestation, water usage, chemical pollution, and energy consumption. Each year, the industry consumes over 400 million metric tons of wood, contributing to habitat loss and climate change, though sustainable forestry programs, such as FSC certification, aim to mitigate these effects by promoting replanting and biodiversity protection. However, illegal logging remains a persistent challenge, especially in developing regions. Papermaking is also highly water-intensive, with some mills using over 10,000 gallons per ton of paper, and the chemical processes involved can lead to pollution if not managed properly. Advanced wastewater treatment systems and closed-loop water recycling processes have helped reduce water usage and harmful discharges significantly. Energy demands in the industry, historically met by fossil fuels, are being increasingly addressed through renewable sources like biomass boilers, often powered by wood waste. Thank you for watching. If you found this video informative and learned something new about the fascinating history and process of papermaking, please give it a thumbs up and share it with others who might enjoy it. Don't forget to hit that subscribe button. Let us know your thoughts or questions in the comments below. We'd love to hear from you. Thanks again, and we'll see you in the next video.